Wow, thanks so much, Brad. That was an awesome expose of some of the questions that the young stars asked over the year. And you might imagine that they only asked more questions.
Exactly.
So this is very
questions
typical.
lead to more questions.
Absolutely. This is typical of the scientific process. The questions get answered, you move on, you have many more questions. And I'm counting around 30 more questions. So we don't have a lot of time, but maybe I was thinking I could just quick fire some questions at you and you can just try to give, almost one sentence answers.
Yeah, we'll
on these
get through them
questions.
as quick as we can.
Awesome. So you were just talking about aliens, so I think this is a great place to start. So recently there has allegedly been a discovery of life in Venus's clouds as the temperature and life conditions are fairly decent. So what does this imply? Can we elaborate upon it, expanding our knowledge whilst using this to our advantage? And will this be a turning point for the human race? So this is probably the hardest question. I'll start with this one.
It really is. I think, firstly, there could be lots of different things that cause this. Life is one of the potential things. There's lots of things that have to be ruled out. But I think the biggest answer here is we often get stuck with our idea of life here on Earth. But there may be more than that. And I know there's other related questions to this about water. We only focus on this because this is the only planet we know of that has life. Now, as we start searching these places, we may find life does it. Just as we didn't know other planets existed until we start finding other types of life, we don't even know what life really means. So this is why we get excited, because it's trying to answer that fundamental question of what is life.
Awesome. Okay, so from life, let's go now to planets. And I think you briefly mentioned kind of like collapsing, rotating things, kind of conserve their what we would call angular momentum, and spinning things keep spinning. So why does the Earth spin on an axis? So why is it spinning around on an axis?
Yeah, that's great. And lots of planets in our solar system spin on an axis as well. Mars is similar to us. Mercury does it. Uranus is on its side. So we think some of them could be of those, we talked about those collisions in the early solar system where there's lots of small things bumping around each other. Well, if you get bumped enough, maybe you get tilted. And we do believe that something like Mars crashed into the Earth to create the moon. So maybe that gave us our tilt. And that's probably the best reason why we have some of those, is those early collisions in the solar system.
Awesome. So Eric, that was your question, I think. So it could be something to do with colliding planets. And Ellie actually asked, why do some planets like Uranus spin on a wonky axis? So I think you also answered
exactly.
That
Maybe you just got really knocked over at a long time. But people like to study these tilts because it tells us how the early solar system was forming.
Awesome. So Gwen now asks, what will happen once the sun blows up at the end of its life? Is it going to be a supernova?
So our sun is too small to explode, which is good for us. It will expand into a red giant, so it'll swallow up Mercury and Venus and Earth. It will get close to Mars, so Mars will be a better place to live in 5 billion years. But luckily, we do not have to worry about this. And then after it puffs away, it'll just be a white dwarf, kind of this remnant core.
Awesome. So Gracie kind of follows up on this, and I think you may have just answered it, but why will the Earth be alive still when the sun dies?
Yeah, so I mean, it won't be a pleasant place. We'll start heating up. The oceans will boil away. The planet will start to really melt and form, and then we'll probably be swallowed up. And this is after the atmosphere burns off. So I don't recommend living on Earth in 4 to 5 billion years. Hopefully by that point, we have another place we can go.
Let's hope so. So in terms of like measuring ages of the solar system, Milta asked, what kinds of instruments do we use to measure the ages of planets?
That's a great question. So some of them are using these meteorites that we fall on the ground. So there's these instruments we call, there's a lot at ANU we call shrimps. So kind of like we call the animal. And so what they do is they take beams of light and energy, and they look at the elements, and every element has a signature. And what we can do is we can look at those signatures of the elements, and even when different elements come together, create molecules. So hydrogen has a signature, oxygen has a signature, and when you add hydrogen and oxygen to H2O, that has a different signature. And so we can look at all these signatures, kind of like fingerprints or DNA, and put the piece together to figure out what elements or what molecules are in that stuff.
Really cool. So we have these little kind of atomic clocks. So Lucas has just privately messaged me on Zoom, and I think this is a nice question, so I'm going to ask it. Why are all planets round? Does it have something to do with gravity?
So it does have something to do with gravity and what we call equilibrium and pressure. So as you're spinning around, gravity is starting to spin you. So things like the spinning disks, but as you get enough mass and enough pressure, you start to get pulled into that ball. And you can kind of do this when you're, if you're spinning around, when you hold your arms out and you spin around, you start to look like a ball spinning around as you spread your arms out. And that's actually, again, as James, you were just saying, with the conservation of angular momentum. And that's one of the reasons we use this criteria of a planet being a planet as being round, that you have enough mass, therefore enough gravity, and you have enough pressure spinning around to form you into a nice stable thing. Otherwise, you're kind of loose and clumpy and lumpy, and you may fall apart or break apart.
Awesome. So now onto something that isn't a planet. How are asteroids made by Elric?
Yeah, so asteroids are formed the exact same way planets are. They're formed from that initial stuff that created the star and planet. Bits of them start to get pulled together through gravity. But because, as we were just saying, there's not enough of mass and pressure, they kind of form quite lumpy. And so as they start to form lumpy, that's it. If there was more stuff, they would have formed heavier and therefore formed to the nice ball. So that's one of the ways we use this distinguishing between, because asteroids go around the sun just as planets do. And that's why we use that distinguishing characteristic of being round to rule out the asteroids.
Awesome. So maybe now we'll venture onto things outside of our solar system. So why do stars have different sizes? And this is from Gracie.
This is a great question. And it really depends on what was that initial thing that created it. So you can imagine if a big star explodes, there's lots of gas around, a bigger chance to form heavier or bigger. If that star or nebula was smaller, less stuff. And then as we go back, if we go all the way to the Big Bang, there was just tons of hydrogen and helium. And it was really easy through fusion, if you remember us talking about that, to stick that stuff together to form stars. So the very first stars were gigantic, thousands to even potentially tens of thousands of times bigger than our sun. They only lasted for a short amount of time, but they were giant, giant stars. And as those stars exploded, they spread that gas out, so they formed smaller stars. Those stars exploded to form even smaller stars. So we can kind of imagine the next generations of stars kind of after us will be even smaller because of that. So stars are kind of getting smaller and smaller and smaller by the generation.
Okay, now maybe onto something like black holes. Is there an opposite to a black hole, a white hole? Asked Callum.
Yeah, so look, and people think this could be connected to wormholes, that if you have stuff coming in, you have stuff shooting out. What would be a white hole? Theoretically, maybe that there are ways they could exist, but people looked for them and we haven't found them. So it may be one of those things that just exists or we think could exist, but doesn't. There's no reason there couldn't be green pigs with 6 legs on a different planet. There's no reason they couldn't, but it just may not happen because the universe doesn't work that way.
So you were mentioning too about planets orbiting around a neutron star. So what about planets orbiting around black holes? Has anyone seen any? And how is the time affected on these planets? So how do people experience time?
So we've detected solar systems orbiting around, or at least stars orbiting around black holes through what we call these tidal disruption events, these things getting ripped apart. So you kind of assume the planets are there. There may be hints that planets have orbited just by themselves around black holes, and some people have calculated they can definitely exist. Now, as they be ripped apart, they would produce a bit of a light, a bit of a kind of a blip, but not a lot. Now, because you are orbiting around a black hole, as you're asking, it's a great question, time would be different for you. Time would move slower. So, a day would take a really long time. If you're at the event horizon, the boundary of a black hole, a day could go on for millions and millions of years. You don't notice it though. That's the cool thing. It just seems normal to you. So it's kind of like, imagine all of a sudden, every school day was 13 hours long. Now that sounds really terrible, but if that's just how school was, you wouldn't really notice that it was long. That's just what happens. So that's kind of how it'd be. You wouldn't notice that it's long because it's just always been long.
Awesome. So that question, by the way, was from Troy. So where do we want to go now? There's a lot of astrobiology questions, actually. Has anyone found life on Mars, by Suzanne?
So no, I mean, so life has never been found on anywhere but Earth. There's been signs of it and hints of it, and I actually think they'll find it. The new Mars rover from NASA, Perseverance, has the tools to look for microbes. I think there's a strong chance to find it. I would be surprised by at the end of the decade we haven't found life somewhere. I think we're that close. But no, we haven't conclusively found life somewhere else.
And what kind of life will this look? I mean, what will this life look like, Brad?
Yeah, look, it's going to be boring. It's not going to be fun. You're not going to be able to pat it or pet it. It's going to be bacteria. It's going to be something small that needs a microscope. But there are other places in the solar system, like the moons of Jupiter. So, like Europa, moons of Saturn, like Titan or Enceladus, that have giant oceans with lots of water that may have complex life. So more than one cell, multiple cells. So, the thing when we think about aliens, we think about life, you always picture things that have two arms and two legs can speak. That's because, science fiction has really evolved and informed our view of it, but there's no reason life has to look like us. Why do we never think of space elephants? It is just as likely elephants exist in space as humans, or space dogs. Now, it doesn't mean that we're going to find them, but we get really stuck on this idea of us, whereas there's lots of life. We never think of plants and trees, right? Grass and flowers and plants. Those are all forms of life. If we discover plants on another planet, that would be life as well. And it's probably more likely than something like us.
Thanks very much. That's that's very interesting. So life most likely won't look like us. So Nicole asked, can we engineer life? I mean, I guess this is more of a synthetic biology kind of question.
Yeah, look, I mean, this is probably a bit outside what a lot of us are qualified to talk about. But I mean, people use medical science and biology to do things to life here all the time on the Earth. What that means for another planet is a big question. And I would say this, and I would say this is probably a better answer when I ask. When we talk about moving to other planets, colonizing, living, growing, we often need to ask the question, should we? It's not always about can we. There's lots of things we can do. There's a lot of things that we should and should not do. And I think the responsibility is on us as we explore the solar system to make sure we're good stewards and we take care of the solar system, not just our planet. So we don't do anything bad, to be honest.
So let's go back to something that's more familiar to astrophysicists, supernova. If a supernova were to happen near the Earth, would we be able to see it from the ground?
Oh, yes. We think Betelgeuse. I'm waiting for this day. We think Betelgeuse will explode as a supernova at any time. So in the constellation Orion, the red giant, that red star in Orion, it's going to explode, any day being 50,000 years. When that explodes, it will approach the brightness of the full moon. So you would be very able to see it. We know from past supernova explosions that humans have seen it with their own eyes. One of the first supernova ever discovered was by Chinese astronomers in 1054, where they recorded an actual explosion with their own eyes. So we definitely know of things that have been seen on the Earth.
Yeah, I would love to see a supernova.
We all would. It would be so cool.
It'd be so awesome. So maybe the last question now, and this is from Nicholas. How big is the black hole in the middle of our galaxy?
So yeah, Sagittarius A star, that supermassive black hole, is about 4 million times the mass of our sun. So 4 million suns squished together. Now to put that into scale, you can put about 1 million Earths inside the sun. So this is an object 4 million times heavier that can fit 1 million Earths in it. So it's big.